selalu diberikan kesehatan. Amin. Yang kedua, saya akan informasikan bahwa webinar ini merupakan webinar terusan yang diadakan PT Gunung Sari Pratama dengan tema Fiber Monitoring System atau RFTS. Di mana tema kali ini kita akan mengusung Nova Fiber, yaitu Intelligent OTDR-based RFTS Solution, designed to build turn up, monitor any type of fiber network, including P2P and PON links. Lalu yang terakhir saya sampaikan susunan acara kami di siang hari ini, yaitu yang pertama adalah pembukaan, perkenalan perusahaan singkat kami, lalu yang kedua adalah acara inti, pemaparan materi, serta Q&A, lalu yang ketiga tentunya acara yang ditunggu-tunggu, seperti biasa, ada acara kenang-kenangan foto sesi, dan juga pemberian apresiasi kepada teman-teman yang beruntung hari ini. Dan yang terakhir tentunya adalah closing. Ya, sesuai dengan susunan acara tersebut yang sudah saya sampaikan, jadi izinkan saya di 5 menit ke depan memperkenalkan perusahaan kami PT Gunung Sari Pratama. Karena pepatah umum mengatakan, tak kenal juga maka tak sayang. Gitu ya. Jadi izinkan saya untuk bisa mempresentasikan perusahaan tercinta kita. Yaitu yang teman-teman ketahui ya, pasti PT Gunung Sari Pratama atau biasa yang disebut dengan GSP. Tentu banyak yang tahu, tapi banyak juga di sini yang bertanya, siapa sih GSP itu? Perusahaan apa sih GSP itu? Dan untuk lebih detailnya, tentu teman-teman bisa mengunjungi kami di website kami di www.ptgsp.com, yang mana pasti banyak sekali informasi-informasi yang informatif yang dapat teman-teman dapatkan dalam mengunjungi website kami. Ya, PT Gunung Sari Pratama atau GSP adalah perusahaan telekomunikasi manajemen. Dan seperti halnya pada umumnya perusahaan, kami PT Gunung Sari Pratama tentu juga mempunyai visi dan misi. Visi misi kami adalah, karena kami perusahaan telekomunikasi, tentu misi kami adalah mempercepat transformasi digital di industri telekomunikasi global. Lalu misi kami adalah menjadi leader company di telekomunikasi manajemen, kemudian menjadi role model company di network solution, lalu menjadi all-in-one provider for passive equipments, dan pasti ingin memberikan solusi SLA dan performance assurance yang komprehensif, dan memprovide up-to-date ICT facilities, dan yang terakhir adalah memberikan IoT facility yang secure. Selaras dengan visi misi kami, aktivitas perusahaan kami adalah yang pertama, test and measurement tools, yang dimana bertahun-tahun kami sudah memprovide test and measurement tools ini kepada Telkom Indonesia. Lalu network solution, lalu network monitoring system, yang mana di siang hari ini kami akan memperkenalkan produk unggulan kami, lalu optical distribution network, SLA performance assurance, ICT facilities, dan yang terakhir, karena visi kami adalah ingin memberikan IoT facility yang secure, tentunya aktivitas kami adalah IoT products and solution. Dalam menjalankan aktivitas-aktivitas tersebut, PT Gunung Sari Pratama mempunyai strategi-strategi khusus, yaitu terbagi menjadi 2, internal dan eksternal. Kami tentunya akan memperkuat internal kami dulu, kemudian kita melanjutkan ke eksternal. Apakah internal itu? Yang internal, kami akan menciptakan, dan yang sudah kami ciptakan, tim yang loyal, brilian, dan dapat diandalkan dari berbagai macam latar belakang kemampuan. Setelah kami menciptakan tim yang loyal, brilian, dan dapat diandalkan tersebut, tentunya kami akan menciptakan SOP atau sistem perusahaan yang terkonfigurasi dengan sistem digital dan sumber daya manusia yang berkualifikasi. Setelah kami memperkuat internal kami melanjutkan ke layer eksternal, yaitu memperkuat posisi perusahaan dengan cara bermitra serta berkolaborasi bersama prinsipal-prinsipal yang profesional sebagai dukungan kami. Sehingga kami akan melanjutkan menuju ke semua layer pasar untuk penetrating seperti pemerintahan dan swasta. Sehingga di mana bertahun-tahun PT Gunung Sari Pratama telah bertahan Bapak-bapak dan Ibu-ibu di pasar, di market dengan baik. Namun sebagaimana kami manusia dan perusahaan, tentunya kami harus berkembang. Tidak hanya ingin survive saja di sini, kami ingin berkembang lebih dari apa yang kami lakukan. Karena big market, ya, masih ada banyak sekali peluang bisnis dan pasar yang sangat besar. Tidak hanya di government, pemerintahan, tapi juga di pasar sektor swasta yang sangat berkembang pesat. Kemudian tidak memungkiri, sekarang ini era digitalisasi, so everything goes digital. Dan tentunya karena kami adalah warga negara Indonesia, dan warga negara Indonesia yang baik, kami mendedikasikan diri kami untuk Indonesia, membangun serta mendukung, mensupport negara kita untuk mendevelop negara tercinta kita, selaras dengan visi misi Bapak Presiden kita ya, Bapak-bapak dan Ibu-ibu, yaitu mengakselerasi digital transformasi di Indonesia. Nah, sekian, tak terasa sudah 5 menit dan mungkin kurang dari 5 menit, kami sudah memperkenalkan dan saya juga memperkenalkan perusahaan kami PT GSP. Tentunya untuk lebih detail dan lebih lengkap untuk perusahaan dan informasi perusahaan kami, Bapak-bapak dan Ibu-ibu juga dapat melihat website kami di www.ptgsp.com. Begitu. Jadi untuk mempersingkat acara kami, kita langsung saja ya ke acara yang kedua, yaitu acara inti kita untuk perkenalan produk dan demo online Nova Fiber. Dan juga dengan senang hati saya akan memperkenalkan pembicara tamu kita. Beliau ini adalah seorang solution sales specialist for fiber monitoring system yang sukses dan juga yang sudah berpengalaman. And ladies and gentlemen, please join me in welcoming Mr. Rishi Kapoor from Expo. Hello, good day, Mr. Rishi.
Yeah, good afternoon. I'm sorry, I was on mute. Yes.
Okay, how are you today?
Good. I'm doing well.
Okay.
How's everybody else?
So, are you ready for sharing your insight?
Yes. I'll start with a small presentation and then I'll move on to a small demo, how it looks like and all those things.
Okay, Mr. Rishi, the floor is yours. Thank you.
Sure. Thank you. Share screen. Can you see my screen now?
Yeah, we can see your slides.
Yes.
Yeah, I can see the slide.
Yes. Good afternoon, everyone. So what I'm trying to do is trying to go through the solution that we have is for FTTH. So the same solution can be used for FTTA or FTTH, both scenarios. Let's start with what we have and how do we look at it. So we have, I'll do a basic introduction of fiber monitoring solution to a FTTH use case, which we have seen in the market, and PON Explorer solution, and then what components does each have, and also on the mobile app, which helps you to add the HRDs. So this is our product profile that we have. So you would have earlier seen we had NQMS and we have FG750s and all. So now we also moved on to RTU2, which is for point-to-point and point-to-multipoint with a smaller form factor as well. So let's go with the use case on, how do we justify the justifying the whole thing. We have first time right to do a drop installation terminals, which is very important. You need to do a pre-dispatch test and post-installation validation. That means all your connection and everything is fine. Then you go into trending of fiber monitoring quality, that you monitor the links and see how is it behaving over time. And then you demark it, you demark the problem before and after the HRD. So generally what we do is HRDs are like a demarcation point, which can be added on your super premium customers, and also probably at the second level of splitter where you can have visibility almost till the building. So what we did is we have actually introduced an OTDR called link aware. So traditionally the OTDRs were built to do basic testing. we do multiple traces, we do combine all of them, and we give you one analysis with that. So traditionally what used to happen was, in a point-to-point link, you could do one pulse, which is the max, and you should be end of the fiber. But in point-to-multipoint scenarios, it's not possible, because you have splitters and you have first stage, second stage splitter, and then HRD. So you need to have multiple pulses to go through each of them. So you need to have enough pulse to look at the close by the event, like what we are seeing here, like almost like 50 meters and 30 meter, and then look at the far events also. So generally, this is how we do it. We have an RTU connected at the C office, and then you can take your HRD. It's like a small 0 dB adapter, and you can install your app on your phone, and you can test whether the links are tested, whether the losses are fine up to the splitter. We have an accuracy of almost 50 centimeters at the end. So what we do is we use 3 nanosecond pulse, and we look at the peak reflectance, and we can detect two HRDs within 50 centimeters apart from each other. This is a standard build, and traditionally what happens is we do build connect kind of a thing. So first you'll have an OLT. You will probably connect the first splitter today, and then add more connect customers, and then have more drop terminal added tomorrow. And then once you have a drop terminal, you will add all the ONT customers at the end. So all this process, what we have seen, is happening in the sequence. So it doesn't happen on day one. It might happen today, tomorrow, and then after 15 days or 30 days. So since we are monitoring it from day one, we know what is the condition of the system on day one, and then we can always compare when they come back tomorrow. So generally what we do is we connect to a DWDM coupler. We do an F1 test. A technician goes with the smartphone app. He connects the small HRD, which is like a passive 0 dB adapter kind of a look, and you connect it, and then you just test whether your F1 is fine or not. So you test it at your F1 splitter. You can test it all the splitter port and see whether all your splices are fine. Is it done properly or not? All the splitter ports are done properly or not? Then once you do that, you take the system, take the HRD to the drop terminal, and the person still has a phone. He does the testing at the drop terminal, which is probably the second, and then at the ONT level. So whenever you're handing over the link to the customer, you look at the end-to-end loss, and if it falls within your budget, then that means there is no problem of optical. It's probably something to do with IP or services that you're doing. So this will help you to actually pinpoint whether the problem is with your optical fiber network, or it is a problem with the data or IP kind of a network. So is it? Should I stop? You need any more clarification, and then I move ahead?
Excuse me, ya, Bapak sekalian, jika ada pertanyaan, mungkin nanti bisa disampaikan menggunakan bahasa Indonesia juga. Silahkan, nanti kami akan translate. Kemudian untuk highlightnya mungkin juga bisa disampaikan. Solusi kali ini kita akan memperdalam terkait solusi untuk XTMS, ya, untuk yang akses untuk jaringan video. Nah, di sini teknologinya sudah lebih canggih, ya, di mana dengan teknologi ini kita bisa mendeteksi event dan splitter. Tadi juga disampaikan di slide sebelumnya bahwa untuk pengetesan misalnya kita bisa mulai dari kabel feeder, kemudian ada kabel distribution, sampai bisa bahkan sampai ke ONT, sampai ke pelanggan. Nah, di sini dengan teknologi tadi sebut island itu memberikan terobosan untuk bisa memberikan solusi yang lebih baik. tidak hanya pada saat sudah di-develop saja, tetapi pada saat pembangunan jaringan bisa, kemudian pada saat sertifikasi jaringan atau tes untuk end-to-end testnya, kemudian pada saat servis aktivasi juga. Oke, Risi, please continue.
Yeah. So this is a very classic example of how the network looks like from the RTU. If you see, we can look at the ports close to the RTU over here on this side. And then we can detect the splitter, which is 1:32, and then the HRDs at the end. So we can detect the HRDs. HRDs can be either placed on the second stage splitter depending upon the customer need, or you can have, your VIP customers can have the HRDs, and you will have a complete end-to-end visibility of there where the break is and whether the HRD is down or not, whether that customer is down due to optic fiber or not. We're using 1650, which is above the standard wavelengths that you're using on FTTH network. We have a fast HRD test. That means you can detect the HRD within 5 to 10 seconds. It can test and see whether the losses are okay. So if somebody goes on the field, he just plugs it in, does a test, everything is fine on the optical fiber, and he can move on. So you have all the results with you in the system, and the person moves on saying that this customer is installed and is now ready to go. Some of the key features and benefits that we have. What we do is we capture multiple baselines, fault quickly. So that means we do multiple pulses to detect the fault. Okay. We don't need no calibration because we have our own system that takes care of it. We also have something called a stone generators. Generally, what we have seen is on the splitter side, there is always a problem of connectivity. The field guy says that I've connected to the right splitter, but you're not getting anything from the ONT side. So we have a tone generation available in the system. So you can use a tone receiver, and you can then detect whether the tone is coming from which link or not, or which link RTU is connected to. So do that. Plus, we have a REST API for all the functionalities. That means we can do everything on REST APIs. We have a trending and tool called Grafana, which can do analysis of each and every event 24/7. And of course, the tone generator, which I spoke to you about. So it tells you what is the total distance of the link along the splitter and everything. So, yeah.
Sorry, I think it's important. We need to highlight this. Baik. Ya. Rekan-rekan sekalian, ini menjadi salah satu key point dari sistem FMS ini. Yang pertama, berbeda dengan OTDR, ya, bahwa sistem ini bisa melakukan multiple acquisition, ya. Jadi bisa melakukan capture untuk mendapatkan baseline dengan pulsa yang berbeda-beda. Nah, sehingga memiliki keunggulan dia bisa mampu untuk mendeteksi fault atau gangguan atau event-event itu dengan cepat. Nah, kemudian juga dilengkapi dengan aplikasi di mana misalnya pada saat dia ingin melakukan deteksi di ODC atau mungkin ODP atau bahkan saat dipasang di customer atau misalnya VVIP customer, itu ada aplikasi yang bisa digunakan untuk mendeteksi apakah dia posisinya sudah benar atau tidak. Kemudian selanjutnya sistem ini 100% bisa diintegrasikan dengan sistem yang lain, misalnya dengan sistem yang Telkom punya. FMS ini bisa untuk diintegrasikan dengan API. Nah, kemudian yang menarik lagi adalah bahwa sistem ini dia bisa mendeteksi atau bisa mendapatkan trending, ya, trending dari hasil ukurnya. Ya. Karena ketika dia pengukuran biasanya pasti naik turun, tapi dia akan mendapatkan statistiknya, dia ada trending datanya ya, untuk semua elemen yang terdeteksi di situ. Bisa jadi kondisi splitternya atau kondisi yang lainnya. Kemudian yang terakhir adalah di sini RTU2 itu bisa menghasilkan source atau tone ya, untuk bisa digunakan sebagai identifikasi fiber. Misalnya untuk mendeteksi apakah jalur atau customer yang dipasang itu sesuai dengan jalur yang benar, atau bisa mendeteksi misalnya apakah pendataan ODP misalnya itu berada di grup ODC yang sesuai. Nah, jadi itu bisa digunakan juga untuk mengidentifikasi. Jadi sangat powerful sekali, dan saya kira ini yang bisa membantu atau memvalidasi data yang ada di lapangan. Baik, oke.
Sorry, I was on mute. Yes. So I'm moving ahead.
Okay.
So what we are doing to what happens is it helps you to reduce network visibility is increased. It helps you to reduce unnecessary travel to remote sites by 50%. That means if I tell you that this particular link is faulty, then you just need to go and repair that. You don't need to go anywhere else, because when there's a break, you generally don't understand where the break is unless there are multiple customers are gone down. Access you have, so we can create an access right sets for each group. That means this network belongs to this team and they only have an access to it. They get their emails and the NOC gets everything together. We can do that as well. Then we have a real-time notification through emails and through emails, and we have also worked on to get something on the GIS as well. We have an on-demand fiber status for all on our desk, so that means you don't need to go on the field. You just go to the link and say, okay, let me check what has happened to this link, and we can do a test and find out what is happening. Some of the use cases that we have for PON Explorer. So the biggest challenges that we face for build and connect phases, workforce training. We have seen that a lot of the workforce don't know about FTTH. They're used to point-to-point links, and there are a lot of things that needs to be taken care of. They don't do that. End-to-end connectivity is an issue because there's no visibility up to where it is connected. The system tells you to some extent, but it doesn't give you exactly where it is. And then there are a lot of multi-party people. You got field guys, you got NOC guys, and you got everything that goes on. And then you have to have a test and reporting time. So generally, traditionally, what we have seen in FTTHs, a lot of customers are facing problem because the field contractors, they take one trace and they copy paste into all the ports and give you all the traces up. But when you're sitting from the NOC, you can test all the ports and see if all the ports are up, and you don't need to depend on the field guys to give you the report. And then we can check all the connectors, whether your splitters are connected properly or not. And we can also do a non-uniform testing. That means I can test because you will have some customers connected to one of the splitter links, some customers are still not connected. We can test all them together and find out which is where everybody is. And then we can help you reduce the budget loss that is there. Again, by simple end-to-end diagnostic test. It's like a simple test via mobile app to check end-to-end testing if everything is fine. You use mobile app. It's a normal mobile app which works on your Android phones or your Apple phones, and you just need to test that particular link, and you'll be able to see what's happening. Automating or in baselining, so we can do an automate where as soon as you have a fault has been cleared, you just press a button, it automatically baselines itself. Remote RTUs are there, so you don't have to worry about going on the field carrying the equipments. You just need to carry a small 0 dB adapter size of a thing and a mobile phone which everybody has with them. It'll help you check the continuity, length, loss, and distribution side also. So it'll tell you from the splitter how much is the distance, what is the loss, and everything. So So then this helps you that you don't need to train anybody. You just do a test from the knock, live test and report. That means once the field person is there, you do a live test and then he moves out. The speed test is around 10 seconds. That means each HRD I test in 10 seconds and find out what is it. And then I can compare all of them and see what is happening. We also do PON certification. So generally, what we're doing is we're using an PON Explorer, where we're using an ILM feature which helps me to detect my excessive bends. It helps me to detect excessive loss on the non-reflective fault and all the bulkhead damage and everything. So it looks at the reflectance of the bulkheads. It looks at the loss. It looks at the bend also. Because we're using 1650, it helps us to give a better visibility on the bend. Should I stop here, Mervin?
Oke. Baik, tadi ada juga yang penting adalah sistem ini juga bisa digunakan untuk melakukan end-to-end test. Nah, di sini adalah dari tantangan challenge-nya, dari tantangan pada saat deployment dari sistem FTTH, termasuk terkait dengan jaringannya sendiri, quality-nya, end-to-end continuity atau konektornya atau budget loss-nya. Nah, di sini dengan sistem ini kita bisa mendapatkan hasil end-to-end test, ya, lossnya berapa. Kemudian untuk tes dan reporting juga sangat mudah. Kemudian untuk mengetahui apakah elemen dari jaringannya itu sudah masuk spek atau under spek, ini juga mudah karena tadi kita bisa langsung mendapatkan hasilnya, ya. Kemudian untuk continuity juga bisa lebih mudah untuk bisa didapatkan. Next, Rishi. Next, sorry, forward. Next. Oke, here, please. Nah, ini mengapa menjadi penting untuk bisa mengukur end-to-end test? Karena tadi end-to-end testnya akan mempengaruhi kepada losses. Can you break one slide, please? Why important test? Oke, please. Ya. Nah, di sini. Nah, ini yang menarik. Karena tentu bahwa kualitas jaringan itu sangat dipengaruhi oleh kontribusi loss dari masing-masing elemen. Ya, misalnya ada sambungan, splice, atau mungkin ada bending, macroband, atau mungkin ada konektor yang jelek, atau mungkin splitter juga yang ada spek. Nah, di sini akan sangat mempengaruhi kepada service atau kualitas layanan secara umum. Karena itulah sangat penting untuk bisa menjaga bahwa loss budget dari jaringan itu masuk dengan standar sebagaimana yang sudah distandarisasi oleh Telkom. Nah, dengan sistem ini kita bisa dengan mudah untuk mengetahui di mana titik-titik yang misalnya konektornya yang jelek, yang lossnya besar, atau mungkin di situ ada macroband, atau mungkin ada sambungan yang lossnya juga jelek. Jadi langsung diberikan notasi, diberikan titik bahwa di sini warna merah, berarti dia melebihi dari standarnya, berarti ini under spec. Kalau yang warnanya hijau, berarti itu adalah spek. Nah, sehingga mudah sekali akan membantu kepada tim, kepada Telkom untuk bisa melakukan perbaikan. Jadi untuk event-event yang under spec akan mudah sekali untuk bisa diketahui. Oke, Rishi, please continue.
So let's go to the monitoring and troubleshooting challenges that we face. You need to avoid customer premises. That means I don't want to go to the customer premises every time. I want to go if there's something which is bad or there's a problem. I need to have an open fiber model. That means I need to know what my network looks like, volume and variety of issues. So I need to know what is the issue, how I can take care of it. I need to have my contractors information with me. Need to have inventory. I also need to see how is my fiber trending and natural disasters. So for example, we have something called Grafana, where you can look at your fiber trending over a period of time. And then you can see how is it behaving, each connector, each splice, each splitters, how is it behaving over a period of time. And also it helps you to get the right field dispatch instead of first sending somebody, he does a test and says, oh, no, it's not this side, you need to look at the other one. So it helps you to avoid that finger pointing. Your demarcation with HRD will help you that. That means if all your key customers, you can have an HRD, and you can put all the HRDs at the last splitter so that you can get the visibility till the premises. And only for the VVIP customers, you put the HRD, so you have a visibility till the end. We have an automatic fault analysis. That means it will detect the fault and tell you which link is gone down. We can do a 24/7 end-to-end test on demand. So we need to know what is monitoring. Again, we do have an open API. That means if we need to integrate something or we need to get some data out of the APIs, we can do that. And the system is scalable. That means I can go up to 1024 ports with one RTU with 3 USIs. So this is one of the examples that we have done where we have connected simulated a cut after the F2 splitter, and you have and then we can look at the link and see what is happening. So the reason why we are saying is you need to have an ILM is because there is no one trace that will help you to get the event because of FTTH. You need to have 4 to 5 traces. Only 4 to 5 traces will help you. So if there's a break and your pulse width is right, then you will detect it. If your pulse width is wrong, then you will not be able to detect the event. So if you look at the pulses, all the red shows that at 100 nanosecond pulse, at 500 nanosecond pulse is not clear, but at 200 nanosecond pulse, it's pretty clear. You have 75 nanosecond pulse, it is clear. 2 nanosecond pulse gives you nothing. So it helps you to, since I'm using multiple pulse, I choose and pick the pulse and then decide, okay, this fault is for this particular application. So this is what OTDRs cannot do today. OTDRs are plain single pulse OTDRs. You would only do one pulse, and if in that pulse you get an event, you get an event. Otherwise, you will not get anything. But since I'm doing multiple pulses, I'll at least catch on any of the pulse which is there.
Okay,
Yes.
Okay. Ya, Bapak sekalian, ini juga menjadi hal yang penting terkait dengan teknologi yang sebelumnya bahwa untuk pengukuran biasanya menggunakan OTDR, maka dalam hal untuk katakanlah untuk mendeteksi atau monitoring jaringan FTTH IndiHome itu agak sulit untuk menggunakan OTDR. Kenapa? Karena OTDR harus menentukan pulsanya, ya kan? Ada setting pulsa. Nah, di sini kita tidak tahu persis.
Pawan, maaf suaranya putus.
maaf ada sedikit gangguan. Ya. Dengan adanya ALM, maka dia bisa mendeteksi event dengan lebih mudah karena dia secara otomatis melakukan multiple acquisition. Okay, receive this.
Yeah. So this is what we do. We have monitoring. We can get the alarm from the alarm window, and then you can click on the trace, and then you can find what are the traces happening, what is the deviation happening. So we have, for example, we found a degradation signal, and we found at the 2 kilometers, which is a fault position loss that I found. And if I click on this, I get which one is that location, and then I have a trending tool for 12 hours. So I now look at it and say, okay, so the event has fluctuated a lot, and when it reached this point, there was a break. So we know what's happening for 12 hours. It was not just one time. It didn't happen. So there was after the event came back, there was still a reflectance issue, and we could then see the trending of it going over a period of time. So this is something which is real-time basis, and we can look at the health of this system, and it helps the planning team to decide whether they need to change the splitters or there's a connector which is faulty, which is creating a fluctuation. Because traditionally, the fiber monitoring system are designed to just tell you when there's an event. They do not tell you how did you reach to that event. With the new system that we have called FMS, it's real time. That means every time the system RTU takes a trace, I have a data with me and I can plot it over a period of time. So I can see how is it behaving over time, and then is it just did it happen like one instant, or it is happening continuously, but probably you are not able to get them because it was less than your threshold that you have put. So if you look at this, you got the event here, but this is a threshold. But if the thresholds were higher, you will not get these events. But then this is a problem because your connectors are fluctuating. So this granularity helps you in Grafana to look at a real-time basis how is the health of your network, which the planning teams can look at it and decide, do we need to change the splitters or do we need to change the connectors and everything. Should I go ahead?
Yes, please. Let's continue.
So what we're using is a PON Explorer FMS. FMS, we have built a new cloud native solution where you can have centralized tool. It can one system can monitor 1,000 RTUs, and you can create domains for different regions out of it. And then each domain can be controlled by a different person, and you still use one instance of FMS. That is possible, and you can host it on the cloud because it's a cloud native. Or you can do is you can we don't use Windows, Oracle, or Java. Now we only use CentOS, which is an open source Red Hat, or we can use Linux the way you want to do it. The other thing is we have built security into it, user management security, where you can have access right to each and every guy separately, and then you can auto detect the fiber issue 24/7. So it helps you to pinpoint the fault and also give it to a person who are responsible and not to everybody also. So for example, there is one network which is a responsibility of a team. The alarm will only go to that team because that network belongs to them, and probably the knock guy receives it because knock person has to get all the alarms with him. So all that thing can be done, and they get access to only their system and their network and nothing else. What we have also done is the EMS is purely a web-based GUI. That means you can install a Chrome Explorer, your Chrome, your Internet Explorer, and you can use it. What we have also done is when we take a trace, we have all the trace with us, so you can actually look at each and every trace separately and see what is the problem, and you can do analysis. So if anybody wants to do an OTDR analysis, we share all the traces, and you can look at each and every one separately also, and then we combine all the data and show you like a linear link like this. RTUs. So what we did is now these are cloud native solution FMS. So RTUs become like a client, just like how in a cloud server your PC becomes like a client, and the security is done from the FMS to the RTU directly. So you don't need a DCN, you don't need a VPN. We use TLS 1.2. Probably will upgrade it as the technology upgrades, and within that the communication happens. So it does its own encapsulation of security, and then it does the communication. So it is a pretty secured communication. Being cloud native, and the RTUs just need internet. That means I don't need dedicated DCN. I need internet to the box, and that's it. A stable internet, and I can control it, and it can be anywhere in the world. So what we did is we made EMS scalable. That means it can go up to 1,000 RTUs today. But in principle, there's no limitation, because in technology-wise, there's no limitation, since we can do cluster. We are doing Dockers, where each server microservices can become like a server, and you can have clusters of server doing this. So that helps you do that. We have a full API set. So traditionally, what everybody used to do, or even we used to do, was we used to build the GUI and the software, and then build APIs to talk to them. But now what are we doing is we are building the APIs first, and then the GUI is built on top of it. That means everything that you see in the GUI has an API running behind. That means anything can be done because we have an API for everything that you see in the system. So that's the biggest change that we did in the system. And we got out of Windows, Oracle, and all those licensing. So you don't need to buy any license, because earlier Oracle had a limitation of number of RTUs you can hold, number of data you can hold. We're using Dockers, which is like an open solution, open source. The RTUs are now 1U, and we can give you 2256 port in a half U size. That means I can give you like in 3U, I can give you a complete 1024 ports with the RTU itself. So this is what we do. We have these small RTU ports. So these are like half U size RTU, which can give you 256 port in half U. So you can actually do 1,000 ports with one system, and the form factor is just 3U. So your sizes reduce, your form factors have reduced. We have a TAM kits. So TAM kits are generally used to add our network into the live network of DWDM. We can give you a patch cord based. We can give you a TAM kit based. Or this is something which you have customized for the customer. So this can be built as a customized solution as well, where you have a dedicated rack, and we actually add a TAM kit in. This is possible for us. The other key thing that we use is an HRD. HRDs are nothing but a normal connector with a reflectance, and it has a unique reflectance at 1650, and gives you a peak which can be detected from the far end. So this helps you to look at that connectors from the far end. We can give it to you in a pigtail format. We can give it to you in a patch cord or like a 0 dB adapter, and they work pretty well in the whole network. And so the patent of HRDs are done by EXO, and it's manufactured by SEI, and we can get it done for you, or we can go with them and take a set from there as well. The other thing that we have is a mobile app. So mobile app is used for turning up the links, and it's a very simple way of doing it. You know which link is yours. We can label the links. You click on the link, you select the port, and then you test whether everything is working fine or not. So it tells you pass or fail. It gives you what is the limit of the loss that you have defined is 29 dB, but I'm getting 27.65 that it is passed. The total distance is 30 kilometers, and from the last splitter, it is 175 meters. So it gives you the distance from the last splitter to the HRD, and also the whole link loss in it. So this is very good if you're trying to turn up the customer, and if it's a VIP, you don't want to go back to the customer again. And it's a small non-expensive HRD, which your field guys can have, and the mobile app. And he just need to select the route, select the port, and do a test. That's it. It's as simple as that. And then we also have something called as tone generator. So generally, what happens is we say that this link is connected to this splitter and this network OLT, but sometimes it is not. It is wrong connected. So what we do is we have a tone generator available in the RTU. So you just need a tone receiver at the end and check which fiber is getting that signal. Once you know that a particular fiber is getting that signal, you can connect the HRDs and test it again. So it helps you to go back and check what it is, try to remove the cable, try to test it up. Since we have a tone generator on the RTU built in, you can always test the link and see which one is right connected. So, so how does it work? We define the topology. That means we have a 1:4 splitter and 1:8 splitter, or whatever the configuration is, or a single stage splitter up to 64, or a dual stage splitter. So we feed that information to the system. That means we are connecting a 4-port splitter and a 8-port splitter, so that we know that if I see a loss in the system, then that is where the splitter is, and it automatically puts the splitter over there, in that location. So this is the basic navigation app for the software.
Tinggal dilem aja ya.
Should I go on?
Yes, please.
So generally what we do is we click on the link. It tells you what all routes are available. You select the routes and you go here, or you can do a search and then get to the ports. Now ports can be labeled as per your requirement, and then whenever you want to test that port, you just say test. And if you don't get any tone, then we have a tone generator in the RTU. You select the tone generation option, and then with the tone receiver, it will detect whether which fiber is connected. Once you know which fiber is connected, then you can connect the HRD to that port and then test again. What is the loss, the distance from the splitter, and everything. So it gives you ease of work, because most of the time, since these are HRDs and splitters, splitters are very difficult to say which leg is connected to which one. Sometimes somebody connects it by mistake a different leg. If you have a tone generator, it helps you to find out which leg is connected to your OLT, and then you can test it. So it helps you to do that as well. Otherwise, you need to go back, disconnect everything, connect everything, check where the problem is, and all that. What we also do is, whenever you do a test, we give you a pass and fail information. It tells you what is the limit, what was the loss, and whether it was within the limit or not, and what was the distance from the splitter, and the total distance of the link till the HRD from the OLT. So it gives you all that information in like 10 seconds. And once you have that information, you can probably connect the network and leave, because now you know that this data is there. And this information goes back to the system. The system always has that data with it. So this is it from my side on the presentation. Any query that you have or anything that I can go through?
Mungkin ada pertanyaan, Bapak Ibu sekalian, sebelum akan dilanjutkan dengan demo online-nya. Okay, Rishi, please continue for demo online.
Just give me a minute.
Sambil menunggu, jika memang ada pertanyaan dari teman-teman Telkom, silakan bisa disampaikan. Tentunya seperti biasa, kami akan memberikan hadiah, gift, kenang-kenangan untuk pertanyaan terbaik hari ini. Silakan Bapak-bapak dan Ibu-ibu, jika ada pertanyaan langsung saja disampaikan kepada tim kami. Ini udah demo online nih ya Pak Wawan ya?
Iya.
Iya,
sambil menunggu saya akan summary lagi ya.
Iya,
memang,
siap.
Kita mencoba untuk berusaha mendengar dengan seksama ya, karena memang ini juga menjadi pengalaman kita untuk bisa dengan bicara dari luar ya. Secara umum tadi sudah disampaikan bahwa solusi ini disampaikan bahwa kita menggunakan filter yang disebut tadi HRD, itu High Reflectance Demarcation. Jadi HRD itu filter yang kecil seperti konektor atau bisa juga dalam bentuk pigtail, itu digunakan
Halo Pak Wawan.
Halo Pak Wawan, suaranya hilang Pak.
Ya, maaf.
Ya, bisa diulangi kembali
maaf.
Pak, tadi agak terputus-putus.
Oke, baik. Ya, pada solusi ini kita menggunakan sebuah filter yang tadi disebut sebagai HRD, High Reflectance Demarcation. Ini digunakan untuk mendeteksi elemen tadi ya. Misalnya kita mau deteksi splitter di ODP misalnya. Nah, pada saat kita mau deteksi splitter ODP, kita tadi bisa menggunakan aplikasi tadi, ada aplikasi, dan kita bisa memberikan identifikasi untuk memastikan bahwa ODP itu tadi tidak benar ya, tidak ada kesalahan. Karena salah satu challenge atau tantangan di FTTH ini adalah tentang pendataan. Karena semua elemennya adalah pasif, ada potensi kita salah dalam mendata. Nah, dengan adanya solusi tadi, itu bisa tantangan tersebut. Kemudian HRD tadi itu juga bisa digunakan di pelanggan untuk mendeteksi, untuk mengukur end-to-end tadi, end-to-end loss-nya, sehingga kita bisa memastikan apakah loss end-to-end yang di pelanggan, misalnya pada saat aktivasi ada pelanggan baru, nah itu apakah pelanggannya sudah sesuai dengan standarnya atau tidak, ya, sehingga kita bisa lebih mudah dan untuk memastikan bahwa pelanggan sudah sesuai dengan yang distandarkan. Kemudian tadi juga disampaikan bahwa sistem ini bisa mengcover jumlah RTU yang banyak ya. Tadi disampaikan sampai 1000. Ya, bisa sampai 1000 RTU, dan satu RTU bisa sampai 1024 port. Ya, artinya bahwa sistem ini bisa mengcover untuk mass deployment, artinya implementasi dalam jumlah yang besar, karena memang jaringan IndiHome itu besar sekali ya, dan sistem ini bisa mengcover itu. Oke, mungkin tambahan dari saya. Risi, please.
Yes, I'll just share the screen.
Ya, sambil menunggu ini ada pertanyaan dari
It's not letting me share. No, yeah, I got it now. Sorry.
Ya. Sambil menunggu, kita bisa membahas pertanyaan yang ada di kolom komentar ya, Pak Wawan ya. Silakan Pak Wawan.
ya ini pertanyaan dari prinsipal kami terkait dengan status atau stage deployment FTTH Telkom. Itu sekarang apakah sudah selesai, artinya sudah dalam tahap deployment semua atau sudah operation atau masih berlangsung juga terkait dengan pembangunannya. Barangkali ada yang bisa memberikan informasi. Apakah sudah, kalau nggak salah target dulu yang pernah saya dengar itu kabarnya sampai 15 juta ya, 15 juta kompas. Nah, saya belum tahu apakah semuanya itu sudah selesai, sudah tercapai atau masih bertahap. Barangkali ada rekan-rekan yang ada informasi.
Yeah. Should I start?
Okay, Risti, please continue.
Let me open a few more things so that it becomes easy for us to look at. So generally, this is a cloud native FMS that we have in the system. This is hosted in cloud in Canada, and we can access all the units from anywhere. We have units in different parts of the world, and they all talk to the system directly. We are actually dividing the system into three. One is topology, user management, and alarms. So when you say topology, it consists of diagrams. That means we can build a logical network diagram, consists of RTUs and domains. Domain is something which I was telling earlier. That means I can create a domain for each diagram or each port, so that only those guys receive the information for that particular link and nobody else receives it. So and then there's an option to add a snapshot, and so this is one of our demo system where we have deployed in Quebec. This is a link that we are testing. We have on point to multi-point link available. So generally what happens is I'll just show you. So whenever there's an alarm, the link goes red, and then it tells you where the break is, and also you get an email which opens up into a map location where the fault is. So you get an email that tells you, okay, go to this location and then do a geolocation for the FTTH network as well. So if you look at this, I'll just show you how we do this step by step. So what we did is we did a baseline first. That means we added a splitter, and then we added an HRD, and then I wanted to add one more on that. So what I did is I did an ad hoc to check the second HRD with the mobile app, and I could detect it. So you get the same information on the phone, and this is the OTDR trace that you can look at. And you can see you're getting a new peak that has come up. So now I know that there's an new HRD that has been detected. And then what I do is I do a baseline. That means I anchor the HRD that is detected. Now I want to say that this is the HRD which is which I want to make it permanent. So there's an option for you to make the HRD permanent or just use it for testing. Because sometimes the customers just want to use it because for the high value customers, they would like to keep that HRD permanent. But for the low value customers, you just want to see whether the network is up and end-to-end losses are within your budget. So you don't need to permanent it. You can just do the test. So once he did the test on the phone, you have this information over here. So that means whatever test the person is doing on the phone, you get that information here. So he gets the information and you also have. So you have a record of all the things that have been tested right now. And then once we add it, we do a baseline. So once you baseline, then I can detect two HRDs. These two HRDs could be at two different links, and they are about almost the same. One is around about 161 meters. Other one is around about 16. Around, I think so. This is almost like 161 meters, and that is 16 meters away from the 16 plus 161. So then you get all the HRD's information, and you have all the information right from the start. If you click on this one, it tells you that this loss is 0.4 dB. This is a two connector together, and the losses are high. You have a combined loss of 1.57 dB. That means this is a very bad connector. If I want to see, okay, let me see what is it. I can go to the trace. If people like to look at the trace, then I can do that. And then this is the event where I'm getting a loss of 1.57 meter. And then this is the second, and you have a fourth is a splitter, and then the HRDs. So it gives you the health of the system on day one. That means before you do monitoring, it is telling you all the issues that are there in the system, all the connector which is a problem, a splice which is a problem, and which you can rectify. So even this one is a problem where it is giving you 697 dB. Make sure that the fiber is properly spliced. The loss is due to low reflectance APC connector, probably microbend. Try to test two wavelengths to confirm the microbend. So it tells you all the options to check with it. This is within the limit, so it's green. So this gives you the health of the fiber on day one. And then once you start baselining it, then it takes this as a standard. And then you could use this baseline and try to troubleshoot and improve the losses also of the fiber, which we have seen a lot of operators do that. And then we created a break. It tells you where the break is. It's at 14 kilometers. This is at 19 kilometer, which is at the HRD. We have a geo coordinate available which points you to the location. If you click, it takes you to the location where the fault is. So we can map the FTTH network on the Google Map itself, on the Google Map GIS, or we can integrate with any third-party GIS also, if it's required. So it tells you. So we have created a multiple breaks. We have created a break at 8.9, which is before the F1. So it tells you where the break is, and then if you go into a trace, you can always see that. So if somebody is comfortable to look at the trace, then they can always look at the trace and see the break. So if you see the lane, this is ref current. If I so this was a reference trace, and this is my current trace, which there's a break here. So we can look at the OTDR also if you want to, and we can also look at the events as well. So both the options are available in the system. And if anybody wants to do an analysis on the OTDR trace, then you have all the traces. You can download them, and you can look at all the traces if you want. So this is a 3 microsecond pulse that they have done, where both the HRDs are gone now, because these were the two HRDs which are there. Now they are gone. I can't see them. This is your 10 microsecond pulse that tells you. So if you look at this, all the pulses are not giving you exact information. There are few pulses which will give you, few pulses will not give you any information. So when we do multiple pulses, we can look at all the pulses and see what has happened clearly. So this gives you all the information on the system, what are there. It tells you there's a break, there's a deviation at what kilometer, how much loss, and we can look at each and everything properly, and then look at it and say, okay, whether it's before the splitters or after the splitters, all that information is available. So this is more of the measurement. I'll take you to the alarm GUI. So alarm tells you what all alarms are there, all the systems. It tells you there's a break, or there's an this is the link that we are monitoring. It says there's a deviation. I click on this one, so you can look at everything. You can look at the ILM trace, where the problem is, It tells you, okay, there's a break and there's an issue for you. So this helps you to pinpoint where the issue is. And then you can go back to the diagram where your system is from here. So, and what we can also do is create a domains for each of them. Sorry. So this one takes me directly to the network. What we can also do, we also have a list of all the RTUs. That means all the RTUs which are attached, how many routes have been connected to it, which site, which network diagram is it connected to, what is the interface ID, what is the software version, everything is provided on the RTU. So you can click on any of the RTU, say, okay, what is it configured? This is FG. So there is nothing configured. You say route. There's one user configured on that. So we can look at each and everything specifically, and we can then decide what is happening or what is not happening in the system. We look at this one, we go to routes. It tells you we're doing a point to multi-point link, and then we are doing point-to-point links also. So you can, so it's trying to do both the links, and there's a failure. If you look at the last results, it tells you, okay, what was the failure that you have seen. So this has been cleared right now. So this is how we do it. And then we have domains created. Domain is nothing but you say, I need to create a new region. I say, okay. I say save. Okay, so now it is saved successfully. I can say is okay for me. Add an RTU. I need to know what all RTUs are there. So for example, I can go to any RTU that are there. My lab RTU is a lab RTU, and this is the link which is active. I select the link and I say okay, add. Now what I want to do is I want to create users and say okay, only these users will get only these alarms. So all the guys registered will get an alarm. So you can have them to look at it, edit it, and so this actually segregates the whole region for them. So this can be done for domains, so that we can create a different customers, different regions, and they can have a discussion. And they only have an access to that particular system. Do you want me to stop? And any queries that you have?
Mungkin ada pertanyaan sekalian? Mungkin saya tambahkan tadi highlightnya, tadi di demo ditampilkan ya, bahwa bahwa nanti kita perlu mendefinisikan apakah jaringan yang kita monitor tadi misalnya ada dua splitter ya, di ODC 14 dan di ODP 18 sama splitternya. Nah, kemudian dia otomatis akan mendeteksi apakah nanti di situ ada sambungan, ada splice, mungkin di kabel feedernya. Tadi disebutkan istilah F1. F1 itu adalah feeder. F2 itu adalah distribution. F3 adalah drop core ya. Nah, tadi disampaikan. Kemudian jika seandainya ada putus di kabel feedernya tadi di F1, nah, dia juga akan memberikan notifikasi. Dia akan memberikan alarm. Selain kita bisa mengetahui dari diagram yang ALM-nya juga, tadi juga ternyata bisa dilengkapi dengan analisa trace-nya. Jika kita ingin melakukan analisa trace OTDR-nya tadi juga ada, sehingga bisa buat menambah informasi untuk analisis ya. Tapi dengan informasi yang sudah diberikan, terkait dengan alarm, dengan posisi atau jarak gangguan dan semacamnya, atau bahkan kualitas dari elemen jaringan sendiri ya, sudah ada. Misalnya seperti besarnya loss sambungan, loss konektor, atau misalkan loss splitter. Jadi dari situ kita bisa melihat apakah jaringan kita dalam kondisi yang baik atau ada terkait dengan underspec ya. Jadi akan mudah sekali kita untuk menganalisanya. Okay, please continue, Rishi.
Yeah. So this is one. Then what we also have is something called as Grafana, which is analytics tool, which you can log into. Just a minute. Let me explain you what it is. So it tells you, this is like a cable template. It tells you each section, the losses, the events, the distance. So this is like a cable template. It tells you the health of the fiber 24/7. It tells you whether there's a splice, there's a connector, whether there's a negative splice or there's a splice. So that's how it is. So the Grafana, what it does is each time I take a trace, I have all the information here, and it breaks it down into each event, where the length is there, what type of event is it, and what is the loss of this event. So if it tells you what is the loss of this event also. It gives you all this information in one go, and then you keep on monitoring over a period of time and see how is it behaving. This is one. Then we also have so I'll just show you the
your voice.
Mr. Rishi,
Your
your microphone is mute, Mr. Rishi. Hello, Mr.
Sorry,
Rishi.
sorry.
Okay.
Yeah. So should I start again, because I think I was on mute for a long time.
Yeah. Okay, thank you.
So generally what we can do is we can have a platform matrix, which is unique. That means it looks at the health of each and every RTU in the field. It tells you whether the disk is full, whether the CPU is full, or there's another issue, or they're not reachable. So this helps you to do a lot of troubleshooting remotely. You don't need to go to the unit. Sometimes what happens is this, for example, this RTU has a temperature of 42 degrees. That means it is very high. So probably somebody needs to check why that 42 and this 44 dB is so high. So it helps you to do that. It tells you each RTU, how much percentage of memory is used, all the RTU names that I've put, and then all these information. So this gives you a complete health of the system. We also have system that gives you a complete health of the servers as well. I'll try to pull out the data. So this is specific to one RTU only. We can do that. And then we can get you each and everything. How's the health behaving? How's the connector behaving? How's the point-to-point link doing analysis? So this is like a surveillance system, which gives you how many RTUs are there, what are the HRD's last loss, is there any deviation that is happening, is there any element loss or fault present. It gives you all the information for each and every RTU. If I So most of these RTUs are dead. So since they are demo, so we so just want to show that we can do this. It's just that I need to find an RTU which works. Look at this one. So right now I'm getting a HRD loss over here. So so what I want to say is that the Grafana does all the analysis for you, and you can look at it. And this can be with the field guys, knock guys, and the field guys can only get the fault. And then we have something called as alarm notification. If you do an edit, I can create an alarm, and I can when I create an alarm, I can do email, I can do AnyDesk, I can do what do you say, alerting rules. So I can have a lot of notification channel. I can click on it, and then I have available is I can do ding dong, which is HTTP post. I can do Discord. I can do emails. I can do Google Hangout, HipChat, your Kafka, your Microsoft Team, and I can send an alarm on Slack, which is a freeware software which comes along, Hook, and also Telegram. If you're looking at, so we can send an alarm on Telegram as well. So this can send an alarm if there's any alert from the system to your Telegram system or to your Slack or Teams or everything. So this is pretty robust, and it can do a lot of things by sending an alarm. So this is it from my side. Anything else that you would like to look at?
Oke, Rishi. Baik, saya akan menambahkan tadi highlight-nya. Tadi di demo tadi sudah disampaikan, kemudian kita ada tools untuk analisis ya, untuk reportnya, yaitu ada dari Grafana, di mana di sini menyediakan analisis yang lengkap tadi terkait dengan tren loss, kemudian dan semacamnya, banyak sekali. Untuk yang simple, misalnya yang sederhana, biasanya terkait dengan monitoring, biasanya kita perlu jika terjadi gangguan kita bisa langsung dapat alert, di mana alertnya itu adalah di mana berapa jarak kejadian atau lokasinya. Biasanya itu yang simple jika terkait dengan penanganan gangguan. Ya. Namun kalau kita ingin menganalisis performance dari networknya secara lebih detail, nah ini Grafana menjadi satu solusinya juga. Jadi dia menyediakan data yang cukup lengkap. Jadi banyak sekali tadi KPI yang bisa ditampilkan. Barangkali ada pertanyaan atau mungkin ada diskusi atau seperti apa, silakan Bapak sekalian. Kalau sederhananya adalah sistem ini bisa digunakan untuk bisa mengukur atau bisa monitoring jaringan IndiHome ya, FTTH. FTTH bisa, maupun juga yang jaringan yang biasa, yang point to point, yang buat backbone atau buat metro itu juga bisa. Kemudian terkait dengan FTTH, di situ untuk mendeteksi splitter, kita menggunakan HRD tadi ya, filter, high reflectance demarcation. Itu
Pak Wawan suaranya hilang ya Pak Wawan.
Sampai di
Pak Wawan, sorry tadi agak sempat hilang. Ini suaranya bisa diulang ya Pak ya?
Oke.
Ya baik Pak, terima kasih.
Ya, terkait dengan FTTH, maka kita dalam implementasinya menggunakan filter atau HRD tadi yang disebut high reflectance demarcation untuk mendeteksi splitter di ODC, splitter di ODP, atau bahkan kalau kita melakukan aktivasi di pelanggan, kita bisa dipasang di OSP. Tadi sebenarnya sempat disebut juga ya bahwa HRD ini bisa dipasang di titik demarcation, atau kalau di Telkom ada roset ya. Beberapa seminar yang lalu ya, Telkom juga ada rencana untuk mengaplikasikan roset kembali untuk atau OTP ya, untuk sebagai poin untuk membedakan area Telkom dengan customer atau dengan pelanggan. Dan salah satu fungsinya juga untuk memudahkan dalam proses maintenance atau troubleshooting, sehingga tidak sampai masuk ke dalam rumah pelanggan. Nah, di OTP ini jika kita ingin katakanlah monitor sampai ke pelanggan, maka HRD bisa diletakkan di OTP. Ya, itu yang simpelnya. Namun kembali bahwa solusi dari Nova Fiber ini memberikan solusi yang lengkap, termasuk data dan analisanya tadi. Jadi kalau kita memang butuh sampai analisa yang detail, di sini sudah tersedia. Namun kalau yang untuk aplikasi yang lebih sederhana, saya kira tadi untuk kebutuhan untuk mendeteksi underspec, kita bisa langsung dengan mudah mengetahui elemen mana atau titik mana yang underspec, sehingga kita bisa langsung fokus untuk melakukan perbaikan. Atau barangkali ada splitter di ODC atau mungkin di ODP yang underspec yang mungkin perlu di maintenance ya, bisa dibersihkan atau mungkin perlu diganti, sehingga mudah sekali untuk melakukan operation dan maintenance. Risi, please continue.
So this is it from my side. Anything else that you want me to show you, I can show that.
Oke, ya tadi disampaikan bahwa ini akhir dari demonya. Barangkali dari rekan-rekan Telkom ada pertanyaan atau mungkin ada feedback barangkali. Mungkin sesinya memang ini ya, apa namanya, perlu ekstra mungkin disampaikan dengan bahasa yang cukup cepat tadi ya. Tapi secara poinnya tadi adalah Nova Fiber ini menjadi solusi untuk FTMS, sehingga dia bisa untuk monitor jaringan FTTH-nya IndiHome, termasuk backbone-nya juga. Mungkin kalau udah selesai mungkin dicukupkan, mungkin Mbak Wira mungkin bisa dilanjutkan. Oke, Rishi, sorry, this a request from about the slide material. Can you
Yes.
share?
Which one?
Can you share the
Could you
Presentation?
please share your presentation?
Yes,
Yeah.
I will do that. Yes, I will do that.
Thank
I'll share
you.
the presentation.
Yes, thank you. Okay, I think
I'll,
enough.
yeah.
You can finish. You can finish.
Thank you.
Yeah. Thank you, Mr. Risi dan Pak Wawan for the insight. Untuk teman-teman Telkom, semoga ilmu yang disampaikan bisa bermanfaat bagi teman-teman sekalian ya. Dan ini memang produk yang sangat menarik sekali karena tadi saya highlight itu sampai bisa reduce operasional ke site ya, sampai 50%. Juga ada notifikasi gangguannya itu bisa lewat Telegram. Jadi nggak perlu capek-capek, nggak perlu biaya kos lagi ke operasional ini. Kalau misalnya sudah implementasi produk ini gitu ya. Nah, kita sudah nggak terasa nih, udah 2 jam kita bersama. Saya aturkan juga terima kasih kepada teman-teman dan saya mewakili PT Gunung Sari Pratama mengucapkan terima kasih telah meluangkan waktunya untuk bisa bergabung bersama kami di sini di webinar hari ini, serta saya ucapkan mohon maaf apabila ada kesalahan kata yang tidak disengaja maupun disengaja. Satu kali lagi kenang-kenangan kita sebelum kita akhiri, kita bisa foto sesi ya teman-teman ya. Supaya ada kenang-kenangannya nih siang hari ini.
Bisa
Ya,
dinyalakan.
jadi diharap teman-teman bisa menyalakan kameranya. Oh, ya, for Risi and Pak Ben, ya, please on your camera because we will take a photo together. Mr. Risi?
Just a minute.
Oke, bisa dimulai Pak Fajri. Jangan lupa dihitung ya Pak, countdown ya Pak ya.
Oke.
Can you, just
Oke, let's continue Mas Fajri.
can you see my screen?
Oh,
Yes.
yeah, I can.
Oke. Oke. Saya hitung 1, 2, 3, ditahan senyumannya. Oke,
Ya,
terima kasih. Saya
Ya, makasih Mas Fajri, makasih semua yang sudah hadir, Bapak-bapak dan Ibu-ibu. Satu lagi kenang-kenangan dari saya, ada pantun. Pergi ke warung membeli ciki, belinya pasti lebih dari 1. Cukup di sini pertemuan kita hari ini, sampai jumpa di lain waktu. Saya mewakili PT Gunung Sari Pratama, sekali lagi mengucapkan terima kasih. On behalf of PT Gunung Sari Pratama, thank you all for making time to join us here today. Selamat jumpa di webinar lain waktu.
Ya, terima kasih.
Ya, terima kasih.
Terima kasih.
Have a wonderful day. Stay safe and health for all you guys.
Ya.
Ya.
Terima
kasih Bapak-bapak semuanya. Saya mohon untuk mengakhiri webinar hari ini. Terima kasih.
Terima kasih.